Hi everyone, today I'm going to tell you about new updates for my Lego RC project. I got some interesting parts that will improve the reliability and performance of the car. Let's see what's new. All parts printed on a 3D printer is made by my good friend Ainur with his parts store, Boyarsky. You can buy parts by clicking on the link below or by scanning the QR code on the screen. It is very good quality and low prices. The first thing I purchased were the bearing frames. These parts will help reduce friction and improve the smoothness of the diff. Bearings provide more stable operation of the wheels and drive shafts and help prevent melting and abrasion of parts, which is important for longer life. I also now have new connectors with bearings, 2 of them with 2 bearings, and 2 with 1 bearing. These will help reduce wear and improve smoothness, which is critical to the reliability of the design. They help get rid of axle chatter in the seating hull, especially important in prefabricated hubs where maximum stress is placed on these parts. You can buy gimbals, hubs, and carbon axles from another good friend of mine, Andrei Tsapenko. He also sells a lot of interesting parts and solutions for Lego, including he invented his own a 2-to-1-2 collectorless motor that fits Lego. You can buy all of the above by following the link in the description or by scanning the QR code on the screen. I bought 4 iron drive shafts from him, and now I have a total of 8. These iron drive shafts greatly improve the strength of the drive, especially under high loads. The car will be more reliable in operation with them. Standard Lego gimbal may not be able to withstand the load of powerful motors, so you should use steel or aluminum gimbal. Another important purchase from Andrew was metal disc hubs. These hubs allow the installation of metal drive shafts, and the wheels are now bolted through a special hex rather than on the axle. This improves the stability and reliability of the design. Now, I don't have to worry about the axle breaking or the wheel flying off at high speed. There are also bearings inside the structure. It is important to note that the rotation point of the gimbal does not converge with the rotation point of the hubs. It should be taken into account when building that the gimbal will shift relative to the shaft when turning, and it should not interfere with anything. Otherwise, there is a risk of breaking the gimbal. For these hubs I bought special wheels with Hexes. These wheels have a deep fit, which allows to reduce the running in shoulder. The rubber of these wheels is hard and rigid so that at high speed, they do not inflate and do not tear from centrifugal force, but most likely they will have to be glued with glue in the place of contact with the disc. I'm not going to do that yet, but the tests will show. From Boyarsky Corner, ordered a motorama for a Joni Lego Technic collectorless motor from Joni Lego Technic. He has his own channel and is the creator of this motor. About the history of creation and just about Joni's work, you can see on YouTube at the link in the video description. The motorama is the main support frame in the front. It is where the 2838-3200 kV motor is mounted. I have built nuts into the motor arm by heating and drilling into the part to join the two halves together, which provides strength and stability. There are different variations of the pignon, that is the drive gear, namely 10 or 12 teeth, and 4 variations of the spur 42, 44, 46, 48 teeth. This allows you to fine-tune the gear ratio for a balance between speed and traction. The shaft that is closest to the motor output has the heaviest load, since the motor is very powerful. In the first tests I twisted the axle, and I ordered from Andrei Tsapenko carbon axles, which are stronger and harder than standard plastic ones. After that, I have not encountered any problems with the motor. And finally, a little spoiler. In the next video, we'll talk about installing the Joni Lego Technic collectorless motor on the motorama, and do a review of all the electronics that are required for this motor. We will make the first tests of the chassis and see what speed we can accelerate to. Thanks for watching, Lego Engineer. See you soon.